Let's see if we can do this problem. This problem is very similar to the previous problem in that we will need to use stoichiometry in order to calculate our k value. After we get our k value, we will then attempt to calculate the kp value. So we have a 0.5 liter flask to which we've added moles of SO2 and moles of NO2. And after equilibrium is reached, we've created 1.30 moles of NO. Because we have started with just the reactants, no amount of product is present. The reaction proceeds to the right because we would have a Q value of 0. So these concentrations will decrease. These concentrations will go from 0 and increase. We can determine the degree to which the reactant concentrations decrease by the moles of NO formed, and we can also determine the concentration increase in the products by the moles of NO formed. Because 1.3 moles of NO formed, we know that 1.30 moles of SO3 must also have formed, and we must have decreased SO2 and NO2 by 1.3 moles, because the stoichiometry is 1 to 1 to 1 to 1. Once we have our moles, then we can recognize that the flask is only 0.5 liters, so we can divide all of these mole values by the 0.5 liters and plug them into the K expression to solve for K, which is 3.45. Because delta N is 0, Kp is equal to Kc multiplied by RT raised to the delta N, but delta N is 0, so RT, which would be right here, RT raised to the delta N is 1, so Kp is equal to Kc times 1, or essentially Kp and Kc are the same.